Hey there. Hey, and welcome to your video on topic 5.9. This is the impacts of mining. This one kind of covers an entire process that you may not be familiar with, so you're going to want to make sure that you read the section pretty deeply so that you can get all the ins and outs. And even though there's a lot of material here, it's still not the full story. We'll be doing that in class. So we're going to start here on page 311 of your textbook and just go through some basic vocabulary, which is what is ore and what's the difference between high-grade ore and low-grade ore. Ore is a rock that contains a mineral that you're interested in, and we're going to talk about what minerals are here in a minute. High grade means there's a lot of it in there per unit area, and low grade obviously the opposite of that. At this point, you should start thinking about the implications of this. High grade ore means that it's not going to take a lot of work for you to get out of that ore rock what you want, because you don't just use it right when it comes out of the ground. You have to go through what's called a refining process. It also means that you would potentially have to dig up less land in order to get what the amount of mineral you were looking for, or that would help you turn a profit or whatever. And especially the refining process uses a lot of fossil fuels and a lot of fresh water. So having a high-grade ore means that you have to use less of those. And again, it also means that you have to disturb less habitat. The lower grade ore that you have, the more of it you have to harvest in order to get the amount of whatever the mineral is that you're looking for. The more fossil fuels you'll have to use during the refinement process. The more fresh water you'll have to use, and the more land you will have to essentially destroy to get at it. So, and when we're talking about high grade and low grade, we're going to address this here in just a minute, but it's all about economics. Just because there is a mineral that you're looking for somewhere doesn't mean that it's economically feasible to go get it. It may just flat out cost you more to harvest it and refine it than it does to actually than what you would get when you sell it. So just because it's there doesn't mean that it's economically feasible to use. Okay, so that's the background. Note examples of both metallic and non-metallic minerals that are mined for profit. So you can see that there's a whole list here. Metals include things like aluminum. Now, steel is not an element. Please, I'm not going to test you on this, but please do realize that steel is a what's called an alloy, which is a metallic mixture of iron and some other things to give it certain properties. Manganese, cobalt, chromium, copper, gold. I can never say this word, molybdenum. It always makes me sound like I have a cold. These are all metallic elements that we use. Now, the cool part is things like aluminum, once you dig it up and use it, you can, provided people don't throw it away, you can then recycle it by melting it down again and making the same stuff over and over. Some of these other things, depending on what they're built into, it's a little bit more difficult. Please realize that this is important here. Gold, its primary use is not jewelry, it's electrical equipment. All of your computers, right down to your phones, have traces of gold in them. All right, let's go ahead and look at the non-metallic ones. We have sand, believe it or not, is a mineral that is mined. Gravel. Gravel and limestone are two things that are mined here rather extensively. Please do remember that the chemical formula for limestone is CaCO3. That's calcium, carbon, and 3 oxygens. And then phosphate is not a formula by itself. It would be something like calcium phosphate. And as you know, that's the K and NPK, and so that's going to be inorganic fertilizer. This says certain detergents. Phosphate is no longer used in detergents anymore once we realized that nitrates and phosphates were two of the things that led to eutrophication. So most dish detergents in the United States no longer contain phosphates, and that was not a government thing, that was a consumer pressure thing, so kind of cool. Okay, so let me go ahead and look at the next set of questions here. We have, what is a reserve? A reserve is an estimate of the supply of a given non-renewable resource Again, these are non-renewable. It's not like growing trees. You have what you have where you have it, and that's pretty much it. Now, this word is kind of tricky because you can see it can grow when you find new profitable deposits. It also is not a number necessarily people share with other folks. As an example, Saudi Arabia is known as having the greatest reserve of oil. Oil is not a mineral that you mine, but this is just an example. Who knows exactly how much they have? They're not sharing it with anyone. So sometimes the numbers in terms of how much of a reserve you have is a closely held secret. Okay, so economically depleted, I kind of touched on that already, but it's right here again. When it costs more than it is worth to find, extract, transport, and process the remaining deposits. So at that point, you've got choices. Recycle or use existing supplies like aluminum cans, waste less, use less. This is always the best choice. Find a substitute or do without. Again, it is what it is. You can't wish more copper or gold into being. It's there or it's not. Depletion time is the time it takes to use up a certain proportion, usually 80% of the reserves of a mineral at a given rate of use. This oftentimes is used as a mark for environmentalists as to whether or not to go ahead and harvest a certain deposit of a mineral. As an example, if there's a deposit of a mineral and it's in very sensitive lands that are protected where there are a lot of endangered species, and let's say that if you harvest every little bit of that mineral that was there, you'd only have a depletion time of 6 months. Like, it would be used up that fast. The question would become, should we allow that environment to basically be destroyed in order to get only 6 months worth of a particular mineral? Now, people who are interested in selling that for a profit would say absolutely. I mean, that's what it's there for. But folks who are interested in conservation may say things like, no, that's like a drop in the bucket. So let's go ahead and find a larger reserve somewhere else and leave this particular area alone. So mining, because of how destructive it is to the environment, becomes very much a hot button issue in terms of whether or not it should be done and what should be done to the land after the mining is over. Okay, one of the other non-metallic, I forgot to say, elements that's mined regularly that wasn't on that list is coal. Coal is still one of the number one things that's burned in order to create electricity. There's a process that basically is as old as, I mean, it's a couple hundred years old. You're basically boiling water to create electricity. So that's also something that's mined. Okay, so what 5 countries supply most of the non-renewable mineral resources that modern societies use? So here again is depletion time. Recognize what depletion times look like on graphs. Remember that this national exam is going to be pretty graph heavy, so be able to read a depletion time graph. Right here. The US, Canada, Russia, South Africa, and Australia. So pretty much the 5 countries that you would expect. How does the U.S. obtain most of its metallic non-renewable mineral resources? So, shocking no one, the U.S. has economically depleted some of its once rich deposits of metals such as lead, aluminum, and iron. Lead is also a trace element that we oftentimes use in our computer equipment. It's also, we still make a lot of pipes out of lead. Aluminum, again, obviously, lots of storage containers for food because it's light, and then also it doesn't react with a lot of things. And then iron is a precursor of steel. So most of these come from reliable and politically stable countries, or at least politically stable as of when this book was published. What happens when a country becomes politically chaotic? Let's say there's some sort of coup or regime change or something going on, you don't have any exports. So that means that if we were dealing with countries where they're kind of going through a time of chaos, we wouldn't be able to depend upon them for minerals that we're looking for. And then you can also see that platinum is another thing that is used in computer wiring, especially computer chips. All right, so Generally note what rare earth metals are used for. That is, I just saw it. They are in here. So these are scandium, yttrium, and other stuff, including lanthanum. You do have a periodic table there on Supplement 3, page S6. If you haven't taken chemistry, please take a look at it so you kind of are familiar with what these things look like in terms of the abbreviations of their names. And this is why they're important. Superior magnetic strength and other unique properties. Remember what metals can do. They conduct heat and electricity as well. So right here, rare earths are used in a lot of computers. They're used in television sets, anything that makes a light, light bulbs, solar cells. You can see that they're a part of the modern fabric of what we do. I mean, batteries, motors for electric and hybrid cars, catalytic converter systems. Oh my goodness. I mean, you just read this whole list and you're like, holy Hannah, how did we live before all of this stuff? The answer is without technology. Let's see. How do governments in developed countries help to support private mining corporations to keep costs down? All right, so this is really interesting right here. China produces 90% of the world's rare earth metals and oxides. That is absolutely a country that it's interesting to deal with, so always something to kind of keep your eye on. We will talk more about politics towards the end of the class. And you can see here Japan is almost as bad. Well, they're in worse shape than we are, and we only have one rare earth mine. And you can see right here, this is also why dealing with China is interesting from a political and an ethical perspective, because the mine that we used to have here in California had to shut down because they couldn't keep up with pollution laws. Those laws don't exist in China, which is why they can keep their prices down pretty low. So that is something to consider. Is it worth purchasing these items from places where there not a lot of human rights in terms of protecting workers' health and paying them a living wage? All right, so how do governments support mining? And it's the tax breaks and subsidies. That means that what we pay for, it costs more to mine this stuff. The government is making up the difference. So this is back to the age-old question of if things actually cost what they cost, would that be a way of slowing people's use of these items, therefore slowing how much this stuff we have to dig out of the ground, thus slowing how much of it gets thrown away instead of recycled. So again, do keep in mind that we, our government, as an example, supports these companies to help them make a profit. Otherwise, they would go out of business. Let's see. I've already kind of talked about the drawbacks of mining lower quality ore, but let's go ahead and take a look. So please make sure that you read all of this in here, especially in terms of what sorts of resources are used. Keep in mind that you cannot say things like mining lower quality ore is bad for the environment because it uses too many resources. What are you talking about? You need to be very specific, especially with the refining process right here. It takes more energy, which comes from fossil fuel use, which then as you burn it produces pollution, which we haven't discussed yet. Again, that cost comes from using more energy. And then also, again, the fresh water that's required for the processing. Let's see. So please make sure that you read all the way down. Biomining is an interesting topic. It won't necessarily be on the national exam, but if this is the kind of thing where you're looking to go into genetic engineering, this is a subset of that you may be interested in. What is a hydrothermal vent? Oh, that comes. How might the world's oceans help to support the need for minerals? Well, because there's a lot of them down there, and they're very far down, so they haven't been harvested yet. Hydrothermal vents are places where chemosynthesis takes place. There's an entire ecosystem down there based upon non-photosynthetic creation of sugars. So there are bacteria down there that use sulfur-based compounds and the extreme heat of what are called black smokers to go ahead and create that first layer of life that then all of these other organisms down here can thrive off of. I'll have to make sure I show you a couple-minute video of what these things look like. If you do want to look up two of the weirder critters that live around hydrothermal vents, I highly recommend that you look up lipstick, these lipstick worms, and then also there's a kind of crab called a yeti crab. You have to look at it. If I haven't pulled it up yet, it's hilarious. But you can see that there's copper, lead, zinc, silver, gold, and some of the rare earth metals that are down there. So the plus side is it's a new place. The downside is there's still entire ecosystems down there. Mining is a very damaging process. So again, pro con. So we have started exploring, but you can also imagine at this point, because it's not a normal process, it's probably pretty expensive to do. According to some analysts, seafloor mining is less environmentally harmful than mining on land. You know, who's to say? We haven't done it yet. All right, so what are manganese nodules? You can see right here that they are potato-sized bits of manganese that are just dotting the ocean floor of the Pacific Ocean. All that would be necessary is to take literally a vacuum pipe and just suck them up. I say, what do you think a consequence would be of harvesting them off the ocean floor? You would have to think that that vacuum is going to catch some bycatch, and it's going to suck up whatever entire ecosystem is also there on the ocean floor. Let's see. Briefly describe how, and then what's hindering us. It's expensive. Also, when you're dealing with the crushing pressures of the ocean floor, if you have to send people down there, it is inherently harmful, or can be, harmful. All right, so we're not talking about life cycles yet. So different kinds of surface mining that you need to know about. A couple of terms that you need to get fixed in your head, which is overburden and spoils. So basically, overburden and spoils, link those in your mind. Those are positional words. So you have your ore here, and you have dirt on top of it, or whatever, rock or anything. It's stuff you don't want that's on top of what you do want. So when it is on top of what you want, it's overburden. When you scrape it away and put it in a pile over here, it spoils. Overburden, spoils. Overburden, spoils. Those spoils we will get back to because they are a source of pollution that we will talk about momentarily. But I mean, just think about it from a environmental perspective. If you just have a bunch of dirt and rocks over here, and especially when you haven't kept the topsoil up, you have to imagine you're creating these piles of deserts where nothing's going to grow until primary succession takes place. Okay, different types of mining that we're going to be talking about are open pit, strip mining, contour strip mining, and mountaintop removal. The name tells you everything that you need to know in terms of what it is. Open pit mining is where you dig a giant hole down, down, down to get to what you want. So copper, gold, sand, gravel, or stone. Our local university, Florida Gulf Coast University, the now lake that is there, used to be an open pit mine for gravel until it was filled with water, and then the property was sold to FGCU. So I wish they had a picture of just an open pit. I'll have to pull up a picture of an open pit, but it's exactly what it sounds like. They're also cut into the outside of that hole. You've got concentric roads that lead down and back up. In terms of environmental impacts, I mean, again, loss of habitat, biodiversity, loss of biodiversity. You've got exposed soil, so you're going to have soil erosion, which is going to end up fouling the water wherever it washes away to. You've got all of the machinery that you have to use to dig this thing, which uses fossil fuels, which creates pollution. We'll be more specific with the type of pollution when we talk about it. You have a lot of fresh water used to harvest and refine the stuff. Open pit mining, though, is definitely safer than subsurface mining for people because the likelihood things are going to crush you is, less. All right, strip mining, that is exactly what it sounds like. Again, it's like grandma's sheet cake. Shunk, you cut a piece and then you deal with it. So again, overburden is when it's on top of what you want. And then when you take the overburden and move it over here, it is now spoils. All right. Contour strip mining is, hey, you cut along the side of a mountain. So yeah. Mountaintop removal is also exactly what it sounds like, and quite frankly, it is probably the most destructive of all of the types of mining. You literally pack the top of a mountain full of dynamite, if I could say it, and you blow it up, looking for usually seams of coal. So this most often happens in the Appalachian Mountains of the United States, which is, again, a unique territory. After a mountain is blown apart, enormous machines plow waste rock and dirt into the valleys below. So not only you are completely blowing apart the mountain, you are also then pushing rock into the valleys, and it's going to destroy whatever it is that it lands on. Plus, if there's any toxic elements in there, when the water washes on them, they'll be released. In any places where the rock lands, nothing can grow there until primary succession takes place. If it lands in mountain streams, you've created a natural dam, which increases flooding upstream and lessens water downstream. Wastewater and sludge is just kind of left where it is. It's often stored behind dams in the valleys, but they break. And then where does it go? It goes into waterways, sinks into soil, and then those toxins stay there. Especially things like arsenic and mercury. We will talk about the damage those cause when we talk about diseases and other things that happen to humans. So you can see here more than 500 mountaintops have already been removed. So you can kind of see what the impact of this is. Now, I know some of you are like, why do we do this? And the answer is, again, coal. Coal is still pretty close to the number one thing in the United States that we use for the creation of electricity. Natural gas is starting to beat it out, which is good and bad for different reasons. And then also jobs. Mining has been a way of life for the people who live in the Appalachian Mountains for a long, long time. And a lot of them, that's all they do. They don't do anything else, and they don't have the funds to go back to college or to train for another job. This is it. And let's see what else is on the list. What are the ecological impacts of mining? I think I've gone over those. If you can't tell, it's kind of the same thing over and over and over again. We will talk about what's called the reclamation process towards the end of the course. There are laws in place that kind of require that these mining companies put things back together. But as you're going to find in an activity we'll hopefully be doing in class, that's easier said than done. You got to think that it's not going to be the way that it was. Oftentimes companies will go bankrupt so that they don't have to spend the money to go ahead and put things back together again. And again, sometimes damage is done. You can't fix things that go extinct or that are buried under tons of rock. All right. Subsurface mining is exactly what it sounds like. That's when you actually go into the ground through tunnels and shafts. Good news is you get at stuff you can't get to through surface mining. Bad news is it can be very dangerous. We still regularly have tunnel collapses even with our modern technology. Why is this? Because there can be unforeseen flaws in the rock that cause it to collapse suddenly. If you hit a pocket of natural gas, it can explode. So yeah, and then something else I don't think is in your book that we will talk about in class is black lung disease, especially when you are mining coal. There is a type of cancer particular to miners right here that get lung disease from prolonged inhalation of this stuff. So black lung disease is particular to coal. There are other diseases that are particular to different types of minerals. When there are tiny little particles and you're breathing them all the time, your lungs don't particularly care for it. So there is a high risk of dying of cancer if you are a miner in these places. And then subsidence, we already talked about. Subsidence can also occur over mines, especially abandoned mines. If you go to build a building and you don't know that you're on top of a mine, the weight of that building can collapse the tunnels beneath you, leading to either subsidence or a sinkhole. And remember, again, you don't settle gently all at the same time. You can settle kind of haphazardly, which can then lead to your foundation of your building breaking, water lines and gas lines breaking, all sorts of fun stuff. All right, so let's see what else. Compared to surface mining, already talked about anthropogenic drawbacks. Remember, that has to do with humans. All right, what is acid mine drainage? In your book, it goes through it generally. In class, we'll go through it a little bit more specifically, but here's what you need to know. Rainwater either goes through an underground mine or spoils piles. Remember, I talked about that. And basically, here's how it works. Carries sulfuric acid produced when aerobic bacteria act on remaining minerals. So you're like, what remaining minerals? Well, it has to have sulfur in it. So basically, there's sulfur in the spoils along with water, and then bacteria produces sulfuric acid that then will run into streams and groundwater. And so not only will it decrease the pH of the water, which can kill fish, there is another phenomenon which we'll talk about in class where it can release iron ions that are just in the water, and that will can again poison fish and other life that live in the streams. All right, let's see what else we have. We are almost done. So no specific chemicals. Again, the sulfuric acid is not in the spoils. The sulfuric acid is created by the bacteria when it consumes sulfur-bearing compounds and water, and it's one of the byproducts of that particular bacteria's process. Act on remaining minerals. So the chemical, it's not something that happens necessarily in the bacteria's gut. The bacteria actually aids that whole process happening. Internal and external costs associated with mining. Again, what do these things mean? An external cost is something that you pay for later, and you usually pay in terms of your health or in terms of damage to the environment. So they're called hidden costs. Direct costs are what you pay at the supermarket, at the drugstore, supermarket, at Target, whatever. So what you pay for straight up is the cost, the cost that you are familiar with. Raw materials, manufacturing, shipping, advertising, and a profit market, all of that stuff. And then hopefully pay for the people who did all that stuff in between. However, what you are not paying for is pollution that can eventually affect your health down the line. Those would be external costs. And then the external cost of what do you do with the car or the product when you're done with it, and the impact that continues to have on the environment. So please make sure that you take a look at those and tuck a couple of them away, especially for a free response type situation. What is smelting? All right, so let's talk about it. Where is it? Right here. Okay, so heating ores to release metals is called smelting. So you got the rock. What you want is within the rock, that ore rock, and you have to melt it. So here's another set of situational words that you need to put together. If you guys remember, overburdened spoils, that's just the dirt on top of the ore rock you want. Now you take this ore rock, if it has metal in it, and you subject it to high heat. And because different things melt at different temperatures, when the stuff you don't want melts, you can then kind of skim it off the top and get rid of it. Or if the thing that you want melts off first, you can skim it off and save it, and then the rest of what's left, you just throw it away. Basically, differentiation in melting points is how you separate them through the process of smelting. Now, the heat that's required is ridiculously hot. So you have to imagine you use a lot of fossil fuels to do this. You can also see here air pollution that is produced, not only things like sulfur dioxide, that's SO2, the suspended toxic particles, we will talk about that when we get to pollution. Also realize just the particles themselves, the ash can be a problem. Again, you've got water pollution, and then a lot of the leftovers are hazardous themselves and require safe disposal. But here are the two positional words that you need to know. Gangue, whoops, it would help if you could see it, gangue, and tailings. So again, you have this ore rock, and it's got two things in it, the stuff you want and the stuff you don't. When it's within the rock, the stuff you do not want is called gangue. Remember, again, you just have to be able to recognize it. You don't have to spell it. Now, once you get it out of there, it is then called tailings. Okay, gangue is when it's in there, tailings is when it's gone. And a lot of times what's in that tailings is going to be some sort of toxic metal, which you can then see can either be blown away or washed away by rain or leak out of containment ponds and end up in our surface and our groundwater, where they could be immediately toxic to life. They can bioaccumulate and then be toxic to apex predators. It just depends on what it is. So again, stuff you want in the rock, overburden spoils. Okay, in your rock, the stuff you don't want, gangue. Once you get it out and put it over here, it's called tailings. Overburden spoils, gangue, tailings. All right. Look at the core case on page 304. So, flipping. Oh, geez. Hey guys, look. Open pit. And all of these are roads large enough for an 18-wheeler. This thing is enormous. Let me see if they have a, yep, look right here, guys. Oops, sorry. That right there is a truck. All right, so let's talk about how you get gold. So, understand how gold is extracted from rock. So, dig up massive amounts of rock, because gold is it's rare. So you only find it in small concentrations, little bits here and there. The days of being able to pan for gold in California are long gone. Any of those random nuggets laying around got snapped up hundreds of years ago. So you dig up massive amounts of rock. Look at this. Enough gold to make your wedding rings, and wedding rings aren't even pure gold, produce roughly enough mining waste to equal the total weight of more than 3 cars. So, so here's what you do. You take all of that rock, you spray it with cyanide, which is the stuff you use to poison and kill things, onto the rock. This is all outside. That reacts with the gold, pulling the gold out into settling ponds. And then after the solution is recirculated a number of times, the gold does settle out and remove from the ponds. But the rest of the pond is still full of cyanide. Looks like normal water. So that means that animals that happen to stumble across it, including birds, and drink it, will die. Then, stuff leaks, in which case it can go into underwater drinking supplies and to fish and other organisms in nearby lakes and streams where it can kill them. Snow and heavy rains can wash them out. You can see right here, it makes water basically undrinkable. You can see here that it got into a river that flowed through Romania, Hungary, and Yugoslavia, and one of the disasters. You can't fish. I mean, imagine if you have no other source of water, it's kind of a problem. And here's another issue, is when you have countries where they don't have legislation that protects workers, you have people who are dealing with these toxic materials day in and day out, and it can and does eventually poison them over and kill them over a course of a number of years. So again, the way that you get gold is you dig up a ton of rock that has gold in it. You spray it with cyanide outside. The gold runs out in solution, and then you put it into an outside pond, which you stir around for a while, and eventually the gold does settle out, and then you harvest it out, leaving behind the pools of cyanide. And so remember all the things that can possibly go wrong there. So that is a quick trip around the world of mining. We will hit more specifics in class, but that is what you're responsible for at this time.